Hi and welcome. In this video, we will talk about Azure Load Balancer. If you find this video useful, please subscribe and hit the bell icon for the future updates. If you want to learn more about Azure Citrix technologies, you can check out my Udemy course, which is also available in Udemy for Business. So basically, load balancing refers to distributing incoming network traffic across group of backend servers or resources. So basically, Azure Load Balancer, it will help you to distribute the traffic to the backend servers. So basically, this will work on layer 4 in the OSI model. So which means TCP and UDP level. So as you can see in this example, so here we have servers 1, 2, and 3 servers we have, and consider this is a web server. So let's say if your service running on 80 or 443, so you wanted to do a load balancing across 3 virtual machines or 3 web servers. So in Azure, what you can do, you can deploy Azure load balancer. So this load balancer will take care of distributing the traffic across 3 servers. For example, let's say if 100 requests are coming from the user, then it will distribute like 30 here, 30 here, and 40 here, instead of hitting all 100 in one particular server. And also it will check for the health probe. So if there is any issue on the back end, so it will mark this as unhealthy, and it will not forward any traffic to this particular server. Instead of, it will forward the traffic to the other available or healthy servers. So this is how it will make your application highly available. So when it comes to type of Azure load balancer, we have two types. One is public and another one is private or internal load balancer. So public load balancer is basically which is exposed to internet, and this will have a public IP address. So when you configure public load balancer, you will have public IP. This public IP can be accessed over the internet. However, private load balancer, which is not exposed to internet, and it will not have any public IP address. Instead of, it will have a private IP address within your VNet or subnet. So this is the difference between public load balancer and private load balancer. So the use case for this is public load balancer. Let's say if you have an application which you need to expose to internet. For example, let's say your any e-commerce application which your users need to access it from their mobile phone or from their laptop, then you need to use public load balancer. However, let's say if you have an internal portal, HR portal or something, that you wanted to publish it within the corporate network, then you need to use internal load balancer. So this is the use case of public and private load balancer. Let's see the Azure load balancer components. So basically, when we are configuring Azure load balancing, there are some components such as front end IP, backend pool, health probe, and a load balancing rule. These are the high level components. So when it comes to costing, standard load balancer, which basically operates at both level, regional as well as global. So in the regional tier price, so the first 5 rule will be charged at 0.025 dollar per hour, and if any additional rules you are creating for the load balancing, then you need to pay 0.01 per rule per hour. So this is the charge for the load balancing. So again, the data processed, which will be 0.005 per GB. The data which your load balancer is processing, it will be billed as per this standard. So let's understand Azure Load Balancer distribution model. The meaning of this is how Azure Load Balancer will distribute the traffic to the backend servers. So there are 3 methods as you can see here. One is hash method, and then we have session persistence, client IP, and the third one is session persistence, client IP, and protocol. So for example, let's say if you have server 1, 2, and 3, and this is the load balancer, and this is the user. So when you select none or hash based, so the request will go to the LB. From the LB, it may go to this server, it may go to this, and it may go to this. So next time when the user access the URL, again it will go to any of the server and it will serve the connection. So this is called hash based, where there is no persistency is involved. And the second one is client IP. For example, let's say you have server 1, 2, 3, and this is the Azure load balancer, and then we have a user. So when you select client IP as a persistence, the meaning of this is first time the user is accessing the LB URL, so the ALB or the Azure load balancer, it will remember the IP address of the client. Okay, so then ALB will forward that particular request to the server number one. So there is a timeout, for example, let's say 5 minutes or 10 minutes, etc. So for the next 5 minutes, my ALB will always send the traffic to this particular server itself, so it will not send it to other servers. And once this timeout reached, okay, let's say on the 6th minute, the ALB will send traffic to this one, and for the another 5 minutes, all the requests will go to this particular server itself. So this is based on the client IP. And the third method what we have, client IP and protocol. So similarly here we have three servers, and then we have a ALB, and this is the user. So now my ALB will remember the IP and protocol as well. Based on that, it will send the communication to, or it will send the request to the backend. For example, let's say the user is accessing HTTP on the load balancer, and then it will send this to first server. On the user side, if the user try to use the another service which is HTTPS, so again this HTTPS also will go to the same server. So this is how ALB will remember the client side IP and the protocol detail, and it will send the details to particular backend IP. So once the timeout is completed, for example 5 minutes timeout, so once the timeout is completed, on the 6th minutes, the ALB will forward the traffic to some other server. So this is how it will create a stickiness on the backend server. Let's see how we can use Azure Load Balancer to load balance our Citrix Storefront servers. As you can see, I'm in the Azure portal. So I have servers here, SF02 and SF-VM. So these are two storefront servers, and then I have a domain controllers. So we are going to load balance these two storefront servers using Azure Load Balancer. So I have logged into both the servers. So this is my SF-02 server, which is having 10.0.0.5 IP address, and another one is SF-VM, which is having 10.0.0.10 IP address. So both are in the same subnet and VNet. So if I go to the IIS, and if I wanted to launch the default IIS page, so it will redirect back to your storefront server. So if I expand sites under site, I should be able to see my storefront server web, which is apps web. So if I click on browse, it will open the default Citrix storefront page. So this is my storefront server UI. So similarly, if I log into the other VM, so I should be able to see similar page. So this is my second web server. So I branded this as server 2. So if I go back to the other server, so this is server 1. So now we have server 1 and server 2, which is our storefront server. So basically, I have already done the SSL certification binding in this particular servers. So now we need to create some custom text file. This is required for the monitoring before we go ahead with the Azure load balancing configuration. So in each storefront server, you need to go to C Windows inet pub www root Citrix and apps web. So apps web represents your store. So under this, you need to create a text file called as monitor.txt. In our case, I already created this. So inside this text, you can put any text. This is basically required for the health check for the monitors. So here I have mentioned that storefront check from SF02. So similarly, if I go to my another server, I have the same file over there as well. So once you have created the monitor.txt file, so you need to validate that. So when you browse this file, so you should get this text, which is storefront check from SF-01. So similarly, you have to make sure it is working in another server as well. So I'm here in the Azure portal. So from the search bar, we need to search for Azure Load Balancer. So this is the option over here. So once you are in the Azure Load Balancer, you can click on Create Load Balancer. So under this option, so under this, we need to first select the resource group. So I'll click on hub-rg. So then we have to give the name for our Azure load balancer. So I'm going to give as sf-lb. So the region central US. So always you have to choose the same region as your virtual machines or your servers. And under SQU, so you can choose standard, gateway, or basic. So for the load balancer, L4 load balancer, always you need to choose standard one. So basic one, which is the legacy, so you should not select. So the gateway option is only for the NVAs. Let's say if you have a network virtual appliance, let's say a firewall, etc. If you wanted to do the load balancing of firewalls, then you need to go with the gateway. So under type, so there are two options, public and internal. Public, it is exposed to the public internet where you will get the public IP address. So for the internal, which is for the internal network only, let's say if you wanted to expose your load balancer URL or IP within the corporate network, not to the internet, then you need to choose internal. So in case of Storefront, you need to choose internal. Why? Because Storefront is normally exposed to the internal network only. So tier, you can get only one option here, regional. So regional means it is limited to that particular Azure region. Then we need to click on front end IP configuration. So front end IP configuration is nothing but this is the virtual IP or VIP, we normally say in the load balancing world. So this is the front end IP on which your users will hit. Okay. So let's click on add front end IP configuration. So here we need to give the name for the front end. So I'm going to define as sf-front end. The IP version will be IPv4 I'm going to select, and it will ask from which VNet you need to assign the IP address. So in my case, I'm going to use AVD test VNet. So accordingly, you can choose your VNet. So subnet, so it will be AVD test subnet. Under assignment type, you have dynamic as well as you have static. So as per your requirement you can choose, but I always recommend you choose static so that you will have the same IP. So under IP address you need to choose the IP address for your load balancer front end or VIP. So I'm going to assign 10.0.0.20. So you need to make sure this IP belongs to this particular subnet under this VNet. So here under availability zone, you have an option to deploy your front end IP address either in zone 1 or zone 2 or zone 3. So always better to choose zone redundant so that even if there is a failure in one of the zones, so this will not get impacted. So I'll choose zone redundant and I'll click on save. So next we need to define the backend pool. So backend pools are nothing but our backend servers to which we are going to do the load balancing. So let's click on add backend pool. So we need to give the name for the backend pool. So I'm going to define as storefront-backend and backend pool configuration. There are two options here. Either you can choose the NIC or you can manually enter the IP address of your backend server. So I prefer to choose NIC. So let's click on add and then it will ask you to choose the backend NIC of the server. So in our example, as I told you, I have two servers, storefront server SF1 and SF02. So I'll click on add and then I'll click on save. So now we have defined the backend. So the next step is we need to configure the inbound rules. So inbound rules are nothing but on which port you wanted to receive the traffic to your load balancer. So I'm going to define the name for this, which is sf-lb rule. So again, I'm going to keep the IP version as IPv4 because throughout this lab, you're going to use IPv4. So front end IP address, which I already defined in the previous step, we need to select, and the backend, so which is sf-be, and then we need to select the protocol. So protocol, so it depends on your infrastructure. So if you are doing the load balancing using TCP, then you need to choose TCP, or if it is UDP, then you need to choose UDP. So we are not going to choose high available ports. So this is basically help you to load balancing on all ports and all protocols. So this is basically used for the NVAs, etc. So for normal L4 load balancing, so we will not use this high availability ports. So in case of storefront server also, we will not use this. We will go with this TCP. And the port, this is very important. This is the front end port on which your users will access your storefront URL. So in our case, it will be 443. If you are doing a load balancing on port 80, then you need to mention port 80 here. So in our case, it is SSL, then it should be 443. The backend port, so it is nothing but from Azure load balancer to your backend server on which port you have to communicate. So either it may be 80 or 443. So since I already binded the certificates on the backend servers, so my backend servers are SSL, so I have to choose 443. So under health prop name, so I'm going to define sf hyphen monitor, and then protocol I'm going to choose a https, and the port will be 443 because we are using SSL in the backend. So path is nothing but the file which we created for the monitoring, which is monitor.txt in both the storefront servers. So we need to give the path of that. So let's enter this, and then interval, which is 5 seconds. So the meaning of this is Azure load balancer will check for the backend monitor.txt at every 5 seconds. So if the backend is responding, it will mark the backend service or server as healthy. If it is not responding, it will mark as unhealthy, and it will not send any further connection request to the backend server. So let's click on save. So then coming into the persistence, session persistence is nothing but the Azure load balancer. It will make sure that the incoming connection from the user will be sent to the particular backend server. So if you go to the options here, we have client IP and client IP and protocol. So in our storefront case, we need to select client IP. So the moment I select client IP, what Azure load balancer will do, it will remember the user IP, and it will send all the connection to the particular backend server for the next 4 minutes. So once 4 minutes is completed, on the fifth minute it will send a connection to the backend another server, which is maybe storefront 02. So this is how you are making sure that your connection are targeted to particular servers during this particular idle timeout. So I'm going to keep all the remaining options as it is. So enable TCP reset and floating IP I'm not going to choose now, and let's click on save. So once we have this, so the next option will be outbound rules. So we are not going to define any outbound rules for this particular storefront load balancing. So the next step will be we can hit on review and create. So this will review all the configurations. So if the configuration are correct, then it will allow us to create the Azure load balancer. So let's wait for the final validation over here. So the validation is completed. So now we can click on create. So now what it will do, it will create a load balancer with the front end IP and the back end IP as well. Accordingly, it will attach the health monitor. So it will take a while. So let's wait for this deployment. So the load balancer configuration is completed now. So let's go back to the portal and we'll go to the load balancer and we'll see how it looks like. So as you can see, this is the storefront LB. So if I open this, so you'll get all the details. I'm going to browse to settings. So under front end configuration, so this is nothing but the front end IP on which user will, hit the URL. And then we have a backend. So backend is nothing but once the traffic reaches to front end, so it will send back to the backend server. Then we have health probe. So health probe is nothing but it will check the backend server on this particular path on port 443. If the backend is responding, then it will mark the backend as healthy. So then we have load balancing rules. So here we are saying that the front end will be 443. So this is related to the quick configuration overview. So if you go to monitoring, so under insight, you can see some backend monitoring of your servers. So as you can see, this is the storefront front end, and then we have the LB rule, and then we have storefront backend. So and then we have two storefront servers. As you can see, both are ticked as green here. See, so this meaning of this is both are healthy and it is responding to the health probe, so which we have configured, right? So this is how you can verify that your backend are healthy and it is in a good configuration. So now what we have to do, we need to create a DNS entry for this particular front end IP, and then we can give that DNS details to the end user so that they can access the storefront URL, which is load balanced in Azure ALB. So I have logged into my domain controller. So I have launched the DNS console as well. So now I'm going to create a DNS A record. So I'm going to define my URL will be sfweb and the IP address will be 10.0.0.20. This is the load balancer front end IP address. So I'll select all these two and then I will click on add host. Click OK, click done. So now as you can see, we have this sfweb created. So back in the storefront server, you need to go to the storefront console and under server group. So you need to change the base URL. So base URL should be always the load balancer URL. So I'm going to enter this URL, which is https sfweb.avdbus.site. So now everything is completed. So let's open the browser in one of the VM, and then we will try to enter the storefront LB URL, which is sfweb.avdbus.site, and we'll try to access our storefront URL. So as you can see, it is going to server one. So for the next 5 minutes or 4 minutes, whatever the time we have mentioned in the LB rule, so it will go to the same server one. So once the timeout is completed, then it will go to the another server. So let's wait for some time and then we'll refresh, and then it should go to my another server, which is server 2. So as you can see, now the requests are redirecting to server 2. So this is how Azure Load Balancer, it will load balance the incoming request across all the backend servers. So one more thing in Insight, as you can see, now both the VMs are up and running and it is showing as healthy 100%. So let's do one thing. Let's go back to the virtual machine and we will turn off one of the VM and we will see the behavior of the Insight. So as you can see, the moment we shut down the other VM, so the status turned from green to this. So this is how the health probe will detect the backend and it will redirect the incoming traffic to the healthy server. So if I go to my VM and if I refresh this, so as you can see, it will still go to server one. So once server two is available, then it will start distribute the load. So this is how you can use Azure Load Balancer to do the load balancing of your web servers on layer 4.